Assalamualaikum and selamat sejahtera. To get voltage and current equations, we need to analyze the equivalent circuits of the rectifiers using Kirchhoff law or Ohm's law. Firstly, let's start with a single-phase uncontrolled half-wave rectifier with a resistive load. Based on the positive and negative half cycle of the AC supply voltage, the rectifier has two equivalent circuits. The diode is in forward bias when the omega t value, which is the angle of the AC source, is in between 0 to pi. Based on the ideal turn-on characteristics, the diode will act as a short circuit to conduct current with zero voltage drop. Hence, we can write the first equation of the circuit, which is the voltage across the diode equals to 0. Next, by observing the circuit, we can see that the resistive load is connected in parallel with the AC source. Because of that, we can write the second equation, which is the output voltage across the load is equal to the supply voltage. Lastly, we can write the current equation by applying the Ohm's law. When the omega t value is in between pi to 2 pi, the diode is in reverse bias. In this condition, the diode will act as an open circuit to stop the current conduction. Thus, the current equation is equal to 0. Furthermore, since there is no current flowing in the circuit, therefore, the output voltage is also equal to 0. Lastly, by applying KVL, we can obtain the voltage equation of the diode. Based on the operating condition of diodes, a single-phase uncontrolled full-wave rectifier with a resistive load also has two equivalent circuits. First, when diode D1 and D2 are in forward bias. Hence, automatically, the voltage value of both diodes is 0. Next, as similar to the half-wave rectifier, we can see that the resistive load is connected in parallel with the AC source. Thus, the output voltage is equal to the supply voltage. Then, as usual, we can apply Ohm's law to obtain the output current equation and KCL to obtain supply current equation. The KCL is applied at this point. Lastly, we can obtain the voltage across D3 and D4 by applying Kirchhoff law or KVL inside this loop. The second equivalent circuit is obtained when diode D3 and D4 are in forward bias. In this condition, both diodes act as a short circuit with zero voltage. Next, let us look at the connection between the resistive load and the AC source. Although both components are connected in parallel, however, their voltage polarity is opposite to each other. Hence, the output voltage is equal to the negative supply voltage. Later, we applied Ohm's law and KCL to obtain the output current and the supply current equation. And KVL is applied on this loop to obtain the voltage across D1 and D2.